Right, I'm going to show you the binary number system. Okay, very quick tutorial, very quick lesson. So we've got binary number system. Okay, let's give ourselves 8 bytes. So 8 bytes, I'm lying, 8 bits, 1 byte. So we've got 8 bits equals 1 byte of data. So let's give those bits down here. So we're going to have 1 0 1 0 1 1 0 0. Sorry, hand in the way. Okay, notice that we're going this way. Okay, it's not right to left, it's left to right, because this is the smallest, just as a base 10 is. Okay, just in base 10 denary, when you're writing your numbers, I know that you write them this way, but the smallest is over here. And just as the same in your base 10, your denary, we have columns, and each column has a value. And we start with 1. And then what we're going to do, in fact, I'm going to use a different colour pen. We start with 1, and then we're going to double it. So we've got 2, and then we double it, 4, 8, 16, 32, 64, 128. Okay? So it starts with 1. 1 times it by 2, times 2 by 2, you get 4, times it again, and so on and so forth. Okay? So it's doubling. It's actually 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. And that's going to come in handy later. We're going to need to know that in a bit. But for now, just try and remember that you start with 1. That's the lowest we can go. 1, 2, 4, 8, 16, 32, 64, 128. So the next one is going to be 2 times 128, which is 256. But we're working with 8 bits, 1 byte. Now, all you have to do to work out what this binary number is, the decimal equivalent of, okay, is to have a look at the ones, the columns that have got 1s in. We're not interested in the zeros because we have none of these columns. We've got nothing. So what we've got is we've got 1 lot of 32 plus 1 lot of 16 plus 1 lot of 4 plus 1 lot of 1. And then you add them all up. Okay, so we've got, I'm not very good at maths, we've got 5, we've got 21, and then 32, that's 53. So we know that that's 53. Okay, so let's do this one again. Back with my black pen. We're going to have another byte. And now 1, 1, 1, 1, 0, 0, 0, 0. So we've got 1, 2, 3, 4, 5, 6, 7, 8. 8 bits. And again, we're going to put the numbers across the top. Quick change pen. 1, 2, 4, 8, 16, 32, 64, 128. We've got 1 lot of 1. I'm going to go greediest first actually. 1 lot of 8 plus 4 plus 2 plus 1. That's 12, 14, 15. Now, notice this. 15 is 1 less than 16. If I was to add 1 more, okay, to this number here, this one would turn over and all of these would be zeros. So a really easy way to work out a number with all of 1s is basically looking at the next bit column and minus 1, and then you would have the answer. But if that's too confusing, just do it this way, you'll always get the right answer. So that's the binary number system. That's how working out the denary, okay, the denary equivalent of a binary number. So how do we work it out the other way? If I said to you, right, we need the number 96. Oh, I wrote 9. I said 96, but put 99. So 99. How are we going to work this out? We take a greedy approach. Let's put down our bits again and our columns. 1, 2, 4, 8, 16, 32, 64, and 128. Now, I cannot take 128 away from 99. I just don't have that. We always take a greedy approach. We start this end. I've got 0 lots of 128. Can I take 64 away from 99? Yes, I can. Okay, so I've got 1 lot of 64. So if I minus 64 here, okay, and that will give me 35 left. Yeah, it does. So I've got 35. Can I take 32 away from 35? Yes, I can. So I'm going to have 1 lot of 32. So if I take away 32 from 35, I'm left with. I'm left with 3. Okay, so I've got 3 left. I can't take 16 away from 3. I can't take 8 away from 3. I can't take 4 away from 3. I can take 2, so I have that. I've got 1 left over, and I've got a 1. What I could do is, to make sure that I'm right, is I can add these up again. So we've got 1 lot of 64 plus 32, and that would give me 96. And then I've got 1 lot of 2 plus 1 lot of 1, which gives me 3. 96 plus 3 gives me 99. And then I know that I've done that right. So if I had this in the exam, I could do it the greedy approach. If you're anything like me and are terrible at adding simple numbers, you can work it back again. Okay. How do we know if a binary number is odd? If a binary number is odd, this will always have a 1 in this column. Okay, if it's odd, it's going to have a 1 here. So if any binary number whatsoever, if it's got a 1 here, it's going to be odd. Right, there are some exercises in the PowerPoint. Have a look to see if you can actually convert the denary numbers to decimal, and decimal numbers denary numbers to binary, binary numbers to denary. Have a go.